Welcome students. Today we'll discuss about the chapter 3 from class 9 science, and the name of the chapter is atoms and molecules. The first topic of this chapter is the laws of chemical combination, and under this we'll study two different sub laws, and these are nothing but the law of conservation of mass and the law of constant proportions. Let's define the law of conservation of mass. According to this law, the mass of reactant is always equal to the mass of product in a chemical reaction. Let's define it with the help of an example. Here is a reaction of methane with oxygen to give the carbon dioxide and water. In this reaction, the methane and the oxygens are acting as the reactant, and the carbon dioxide and water are acting as the product. The mass of methane is 16 gram and the mass of oxygen is 64 gram, whereas the mass of carbon dioxide is 44 gram and the mass of 2 moles of water is 32 gram. If we take the sum of the reactants, the sum becomes 80 gram, and on the other hand the sum of the masses of the product is found to be again 80 gram. So this reaction clearly shows that the mass of the reactant is equal to the mass of the product, and this is what is called the law of conservation of mass. Let's now define the law of constant proportion. According to this law, in a chemical substance, the elements are always present in definite proportion by mass. We'll explain it with the help of an example. Here you can see that the water molecule, the molecular formula is H2O. It is always contains two atom of hydrogen and one atom of oxygen, which combines together in the same ratio of 2 is to 16, and its reduced ratio is 1 is to 8 by mass. So student, if 9 gram of water is decomposed, we get 1 gram of hydrogen and 8 gram of oxygen. That's all about the laws of chemical combinations. Now we will move to the next very important topic, and that is nothing but the Dalton's law of atomic theory. Next is the postulates of Dalton's atomic theory. According to this theory, all the matter is made up of very small particles called atoms. Atoms are indivisible. Atoms can neither be created nor be destroyed. Atoms of a given element are identical in mass and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. Now let us discuss the symbol of different elements. It was Dalton who proposed some symbols for those elements which were discovered in his time. You can see here in the screen here that hydrogen, the symbol of hydrogen is given by a circle with a dark circle at the center. Similarly, you can see the phosphorus, then copper, then gold, then carbon, then sulfur, lead, platina, oxygen, iron, silver, mercury, etc. So, students are here. These symbols it suffer from lots of limitations. Uh, these symbols are little bit difficult to remember. Moreover, after the discovery of many other elements, it was difficult to give symbols for those elements which were discovered later on. That is why it is the IUPAC committee. They have given certain rules for giving the symbols of different elements. So these elements naturally they have taken the first letter of the name of the element. Some symbols they have derived from the first two letters, and some were derived from the first letter and the third letter. The symbols which are derived from the first letter of the name of the elements are carbon, fluorine, hydrogen, iodine, nitrogen, oxygen, phosphorus, and sulfur. And the elements, the symbols which are derived from the first two letters are aluminium, then bromine, calcium, etc. Symbol of some elements such as the chlorine and magnesium are derived from the first letter and the third letter. While the elements such as the copper, iron, lead, mercury, potassium, silver, sodium, tin, these are derived from some Latin words such as copper is derived from the cuprum, iron is from ferrum, lead from plumbium, mercury from hydrogenium, and potassium from kalium, silver from argentinum, sodium from natrium, tin from stannum, etc. The next important topic is the ions. Any charge carrying species are called ions. There are two types of ions. They are cation and anion. Cations are generally positive charge species, whereas the anion are negatively charged species. Here are some symbols of cations and anions. Uh, Lithium. The symbol of lithium is Li positive, sodium is Na positive, ammonium is NH4 positive, potassium is K positive, magnesium is Mg twice positive, calcium is Ca twice positive, fluoride is F negative, chloride is Cl negative, nitrite is NO2 negative, bromide is Br negative, nitrate is NO3 negative, phosphate is PO4 thrice negative, and sulfate is SO4 twice negative. Now let us learn how to write molecular formula. Before writing the molecular formula, let's define about the molecular formula. Molecular formula is nothing but an expression which states the number of type of atoms present in a molecule of a substance. Let's discuss the molecular formula with the help of the following examples. In the screen, you can see some methods are given here to write the molecular formula of potassium chloride and the calcium chloride, aluminum chloride, potassium hydroxide, calcium hydroxide, aluminum hydroxide, etc. So now let we'll see how we can write the molecular formula of potassium chloride. A potassium chloride is made from potassium and chlorine atoms. So in the first step, we will write the ionic symbol of potassium and the chloride. The ionic symbol of potassium is K positive and the chloride is Cl negative. So here this plus 1 will cancel by minus 1. So the formula will become only KCl. Whereas in calcium chloride, the ionic symbol of calcium is Ca twice positive and the Cl is chlorine is Cl negative. So here one thing happens here. For writing the molecular formula, the charge means the charge of calcium will go with the chlorine, and the charge of chlorine will go with the calcium, and thus the formula becomes CaCl2. Again, in aluminum chloride is made between the aluminum ion and the chloride ion. The symbol of aluminum ion is Al thrice positive and the chloride is Cl negative. So the thrice positive means the numerical term the 3 will go with the chlorine and the 1 will go with the aluminum. Hence the formula becomes AlCl3. Likewise, student, we can write the molecular formula potassium hydroxide as KOH and calcium hydroxide as CaOH twice and the aluminum hydroxide as AlOH thrice.